Hello and welcome to the Chandar Academy. In today's video, we are going to solve the second part of this exercise about the full study of a function, which is here kind of a rational function, but a little bit developed. In the first part of the video, we solved the first question and the second one, and we determined the domain of definition of f, which is equal to all the real numbers except the value -2, because in -2, we have the denominator that is equal to 0, and we don't want that because we don't want to divide by 0. And then we found the limit in minus to minus, minus the infinity, -2 plus, so just to the right of -2. Here we have -2 plus, and in plus the infinity, which is equal here to minus the infinity. In the second part of the video, we will want to find the vertical and the slant asymptote of C, which is the graph of f. And in the first question, we will want to study the variation of the function f and then sketch the graph of f, which is called C. Okay, so first, what is a slant asymptote? A vertical asymptote. An asymptote is a straight line that is approached by f without never reaching it. And we see that in -2, so here in -2, we will have at the left of -2, so in -2 minus, the function that will go to minus the infinity. And we can never reach -2 because the function is not defined in -2, so we will have something that goes like this in -2. And in +2 we come from plus the infinity, so something like that. And here we see that we will approach this exact straight line without never reaching it. The proof is using those two values. And we conclude by saying that this straight line of equation x is equal to -2 is a vertical asymptote. So the straight line of equation x is equal to -2 is a vertical asymptote to C, which is the graph of f. And we have solved, the first part of the question. Then second part, we want to find the called slant asymptote. A slant asymptote is a straight line, so of equation ax plus b, that will be approached in plus. So approaches f of x in plus and minus the infinity. And we can see that when we have the function f on this form, we have here the equation of a straight line, and here something that will go to 0 in plus or minus the infinity. And so how to prove that we are approaching a straight line? We prove that there is y is equal to ax plus b, and we will want to find a and b, such as the limit of f of x minus y of x in plus or minus the infinity is equal to 0. That will mean that if I have a straight line like that, in minus the infinity and plus the infinity, the distance between f of x and our straight line will get smaller and smaller. And so here we see that we already have the supposed solution. Let's call y is equal to x minus 1. Okay, so this one, x minus 1, the supposed slant asymptote to C in plus minus infinity. Okay, how to prove it? F of x minus y of x is equal to x plus 1 minus 3 over x plus 2 over x plus 2 minus x minus 1, so plus 1. Okay, so it was minus x minus 1, and that makes, if we distribute minus plus 1, we can simplify those two here together. And what do we have now? We have minus 3 over x plus 2. And when x tends to plus infinity, this will tend to plus the infinity. When x tends to plus the infinity. When x tends to minus the infinity, of course, this will tend to minus the infinity. And if we have minus 3 over plus the infinity, this is equal to 0. And if we have minus 3 divided by minus the infinity, this is equal to 0 as well. And so this will tend, when x tends either to plus or minus the infinity, to 0. And we have found our slant asymptote. And in conclusion, y of x, which is equal to x minus 1, is the slant asymptote to C in plus minus infinity. And we have solved the second part of our question. Then, last question. So let's remind that for all x in df, we've got f of x that is equal to x minus 1 minus 3 over x plus 2. We will want to study the variations, okay, the variations of f. Okay, and to do that, we will study, of course, its derivative, f prime of x, okay? For all x in df, f can also be derivated, because if x is not equal to 2, we have something that is a polynomial plus an inverse function that does not have a denominator equal to 0 in x, and so that is also derivativable. And so we will have for all x in df, f that can be derivated such as, and we will give the value of f prime of x, the derivative, is equal easily for this one 1 minus what? Minus what is the derivative of that? We've got minus 3 times what? If we've got something like 1 over u prime here, 1 over u here, the derivative is equal to u prime over u squared. And here u prime is equal to 1. So we've got minus 3 times, here we've got a minus, is equal to minus 1 over x plus 2 squared. And so the derivative is 1 plus 3 over x plus 2 squared. Okay, this is x plus 2 that is squared. And this thing is obviously greater than 0 for all x, because 1 is greater than 0, and 3 over something that is squared and not equal to 0 will be greater than 0, because this thing is positive and this thing is positive by definition. And so we will have something greater than 0, and we can conclude if for all x we've got f prime of x, for all x f prime of x greater than 0 means that we have something that is increasing for all x's. So let's sum up this in a variation table. We've got the important values, minus the infinity, minus 2, and plus infinity. Of course, in minus 2, the function is not defined. And here we have something positive and positive. And we know that we go from minus the infinity to plus the infinity because of the limit. And here minus the infinity to plus the infinity as well. And always increasing. And now we have all the elements to be able to graph f. So to graph f, we do a beautiful graph. Here we are going to put 1, here 1, minus 1, minus 2, which is an important point because it allows a vertical asymptote. Now, what is the other asymptote? The other asymptote is, so here we've got minus 1, x minus 1. So here this is x is equal to minus 2. And here we have y is equal to minus 1 plus x. So something like that. We have something exactly like that, which is the slant asymptote of equation y is equal to x minus 1. And we go through the point 0 minus 1 and we have a plus 1 coefficient. Now we know that we go from minus the infinity to plus the infinity before 2 and going near the slant asymptote. Near going the slant asymptote in minus the infinity and to the vertical asymptote in minus 2 minus. So we graph this going very near this slant asymptote, okay, decreasing, and then going near the other asymptote, and in minus the infinity there will be almost the same. Same thing here, we go from minus the infinity this time. We go from minus the infinity, increasing, and going to the slant asymptote in plus infinity. Of course, here we've got y, here we've got x, and we call the curve C. Okay, 2 times here. I'm dezooming for you to see the whole function, and we have solved our problem. We have solved all the questions of this second part of the exam. Hope you enjoyed the video. See you soon. Bye.